This is what I hope will be a quick little tutorial on how you can do some of the operations that are common in our homework sets coming up in Maple. Maple is available on all networked computers on campus. Let me know if you need to know how to access it, but if you're in Gellerson, just go to like Gellerson 160, as long as it's not Tuesday or Thursday when that's book solid with calculus labs, and you'll be able to use Maple. So once you open up Maple, this is what you see. Again, I'm assuming you're relatively familiar with this from before, and if not, it's still easy to pick up. This is what the screen looks like. We're going to open up a new document, and all you have to know in here is that there's two environments, math and text. So math is where you enter all your math stuff, and text is where you type things, and I don't know that there will be any situations where you'll actually need to type things. But if you accidentally find yourself out of the math environment, just hit F5 and it will return you to math. So what we're going to do here is look at how to build matrices and to do common operations for them. Over here on the left is a whole bunch of different palettes that you can work with, and conveniently there's one called matrix. So we're going to open that up and we're going to select the size of a matrix we want to build. Say, I mean, very common is a 3 by 3. So let's do 3 by 3, or even better, let's do 3 by 4. Because then we can build something like an augmented coefficient matrix. And so having selected the sizes, we're just going to click Insert Matrix, and there is a template ready for you to load up with numbers. So let's say you've written down a solution, or written down a system of 3 equations and 3 unknowns you would like to solve. I'm just going to make numbers up right here. So let's say the coefficient matrix itself starts with 2 tab, 3 tab, 5, and maybe the right hand side entry for that is 1. Tab again, and then the second row, let's say the coefficients are -1, 0, and 4, and the right hand entry in that second one is 10, and then how about 0 tab, -3 tab, -3 tab, and right hand side of that third equation 5. I'm going to hit enter, and it echoes back the matrix. And now from here on out, it's all right click and menu selection. So if I right click on this matrix, it pops up a whole bunch of stuff you can do. And down here, okay, don't look at eigenvalues because you're supposed to be calculating these for yourself. Well, okay, you can look at eigenvalues. You can look at eigenvalues to make sure that you get the right answer when you go through the actual process. Okay, but for now, go through the process. Now, that process might involve solving a system of equations, which is what we are in the process of doing. So for most matrix calculations that you'll encounter, you're going to want these two down here, solvers and forms, or standard operations. So standard operations, there you can see pseudo inverse or transpose, and we've talked about transpose a little bit. We've never heard pseudo inverse. If this was a square matrix, you would also see options for inverse and determinant. Right above here is solvers and forms, and in particular take a look at about the 5th item down is row echelon form, and even better, we can roll over here to reduced row echelon form. Just click that, and there is our reduced row echelon form of that matrix, and so now we know the solution to whatever system of equations that was that I made up. Let me build a square matrix just to show you the other options. So here now I'm going to build a 3 by 3. I'm going to insert it, make up some numbers, 1, 0, 1, 0, 1, 1, and -2, 3, 5. What the heck? Now I'm going to come over here and right click on that item. Now I'm going to go down to standard operations, and now I have more options because it's a square matrix. So I could find the determinant, which is 4. Since the determinant isn't 0, there should be an inverse. So I can right click on this guy again, standard operations, inverse, and now there's the inverse of that matrix. So I guess the one last thing to show you would be, for example, let's say you're deciding if something is a linear independent set or if a set of vectors spans a particular space. In either one of those cases, you're going to be solving a system of equations. For the linear independence check is going to be a homogeneous system of equations with a right-hand column of 0. The spanning case, you're checking if you can make a linear combination of vectors and reproduce any arbitrary vector, so you'll have a right-hand side of fixed but arbitrary, i.e. not specified values. In either case, you're going to be working with the same coefficient matrix. So let's say we have a set of vectors and we want to know if they're a basis for a particular vector space. Now, this isn't the time or the place to tell you what the steps are, but let's just say that we've decided that to solve that problem, we have two questions to answer, both of which can be answered with this particular coefficient matrix. And again, I'm just making up numbers. So, whoops, Shift and Tab backs you up. -4, 5, and 2, and then maybe 0, 2, and -2, and how about 1, 1, 1? So this is the coefficient matrix that's common to both the question of linear independence and spanning. I'm going to right-click. I'm going to look for its reduced form, so solvers and forms, row echelon form, and reduced row echelon form. And I see this, and what this would tell me is that these particular vectors are linearly independent, and they do span the particular space I'm in, so they would form a basis. So again, not the time and the place to go into the whys and wherefores of those questions. That's the other slides and the notes and the book, but this is how you can quickly get an answer to that question here in Maple.